Movement. Well, this is the basics of every game, so let's get moving. Okay, so this is where we left off last time, and it's time to make our character move. So let's delete this example script. So right click and remove component, and we can also delete this from the asset. Okay, then click to the player, add component, and add a script called player movement. So it's always worth naming it to something that states what the script itself is doing. So open it up. I'm just going to delete these two using tags and also these comments. Okay, first I'm going to show you the odd input system, and if you are a complete beginner, you can work with this one. Okay, first we need a vector free component, just what we did last time. I'm gonna call it move speed, and then if we go back to Unity, last time I think we had like a 500 and 300. So if we want to go left or right, we need to modify the value on the X on the positive or negative. So I'm just gonna set it to, well, 500 first. And in the update function, we can check in any moment of time if we press the D or the A key. And depending on that, we are going to do something. So the syntax is input dot get key, and then key code, and here dot D, and then obviously need a reference to the rigid body. So private rigid body RB, and at the start function RB equals get component rigid body. So now we just referencing it. So RB the add force, and we need the move speed. So right now I set this to a positive value. So if I start the game now and push it, it just shoots off. Obviously it's because if I check out my stats, I have 165 FPS. So it just shoots off because it applies that force 165 times per second, and it's completely fine. But if I play it on a different computer that has 100 frames per second, then it will have a different feel. So to compensate that, we need something called time.data time. And so what this value does is basically calculates the amount of time between the last frame and the current frame, and if we have loads of frames, then this value is going to be really small, and if we have less frames, the value is going to be a bigger value. And this compensates between the two frame rates, and this is something we call frame rate independent. So if I multiply it by time.data time, this code is going to be frame rate independent. So let's play it now, and it's much less now. Now do the same in the other direction. So let's say this is going to be A, and all we need to do is multiply this move speed by -1, or just use a minus in front of it. So now I can move to the right, and I also can move to the left. Obviously the add force is part of the physics system, so this should be used in the fixed update, but in that case we could miss some of these input values. So what is fixed update? The fixed update is Unity's physics system. So the physics calculations are quite computational heavy. So because of that, these physics calculations are calculated at a fixed rate. For example, 50 times a second. Meanwhile, if we go 165 FPS, the update runs 155 times. If we move the whole inputs get key to the fixed update, then we could lose some data when we are already pressing, but it still needs time to the physics update to recognize. So to combat that, we could do something like a private bool check. So let's say, and create another one is left pressed. So here I could remove this from here. So if I press the D key, then is right pressed equals true. And if I'm not pressing it, so else, then is right pressed equals false. And same with the other one, just is left pressed equals true, is left pressed equals false. Then in the fixed update, if the right pressed, then we got the positive value. So move speed time.data time. And if the left pressed is left. Then we have this -1. Now these are frame rate independent, and the inputs are recognized at the speed of our game, and also the physics systems is running in the fixed update. There used to be a fixed data time, but now the compiler is smart enough. It sees time.data time in the fixed update, then it automatically changes. So right now we can use the simple data time. Okay, so this is one way to do this. The other one is the new input system. So the new input system, you need to install it in the package manager. So window package manager, Unity registry, then find the input system and click install. And it's asking us to restart the editor, so just hit yes and be right back. Okay, now it's installed. So first just check out the GitHub desktop. We made some changes about the player movement script. Here, I just going to save it as old input system. I could do a description about it, but it doesn't matter at this point. So commit to main and push to origin. So I'm just fetching it up. And in the history, I can see these changes about the input system. So new input system. If you right click, create, and there's an input action, you could call it player input and open it up. So I have a dedicated video about this, so I'm just going to link it in the description. And also you can find it in this info card. So first we need to create an action map. So click this plus button here and call it player or ground or whatever. In the actions, we can specify the bindings. So this one's going to be the movement. And in the action type, it's not going to be a button. It's going to be a value because we constantly going to check the value of it. So there's another control type. And here I'm just going to select an axis. Now, if you click on this plus button, there's a positive and negative binding. So if you click on it, it's going to be a one-dimensional axis. So left or right. So the negative one, that's going to be when the value is 0 to -1. And here we can add a path. So if you could manually set it up by keyboard and find the key. But if you just push this listen button and press the A key on the keyboard, then you just select the A. And same with the positive one, and that's going to be the D key. This is it for now. You manually have to save the asset. And one quick thing is we can generate a C# class that we can later on reference in a code. It's not that beginner friendly as the old input system, but it's much more powerful. So I suggest to learn this one over the old one. So let's say you make your first 5 games with the old input system, like a small prototype games, the old input system is completely fine. But once you feel like you want to do a proper game that you are going to release Steam or Apple Store or Play Store, you probably want to go with the new input system. And soon I'm going to show you why. Okay, so player input, we just generate this C# class. So take that and apply. It's going to create this player input script. So this contains all the bindings that we created, like player. Here's the 1D axis and negative and positive. So it has an ID, and it's a complicated one, but we don't need to know anything about this. So I'm just going to close it. So I'm just going to comment it out for now. Okay, obviously here we need to reference it. So private player input actions, and at the start we just create this new player input, and that's it, what we need to do here right now. Okay, and now we can reference this input action. So the syntax is we write down the input action, then we just follow the path that we seen here. So input action dot player dot movement, so dot player dot movement dot, and here we can do all kinds of stuff. Okay, so read value. Between that, we need to specify what we want. Right now, we just want a float. So number of in the minus or plus. So right now we get, well, exactly, we get 1 or -1 if we press the A or the D key. And now we don't need any of these bool stuff anymore. Okay, so I'm just gonna store it in a variable. So private float direction, and the directions equals this one. So in the update function, we are going to check the value of the input action. And in the fixed updates, we are just going to tell rb dot add force going to be the direction, so which way we are moving, times the move speed times the time.data time, and start the game. Okay, one thing is we need to put these not to the start, but before the start function runs, and there's one more function in it called awake. The input actions, well, it's a syntax, and it's just worth doing that because it can cause some memory leak. So simply just do this. Write on enable, and here input actions dot enable, also on disable, and input actions dot disable, and we can forget about it. So now we can start the game. I just quickly create a debug.log to see the direction value, so what we read off from the new input system. Start the game, and right now I'm not pressing anything, so it's only gives us a 0 value. Now I press the A key and it does move to the left, and then the D key and it does move to the right. So we didn't have to do all these stuff. We just simply got a direction value. I used the direction value in the add force in the fixed updates, and no if statements, no nothing. So I think if you learn the syntaxes and how to use it on a basic level, it's much more powerful than the old input system. I'm just gonna show you one more thing. If you open it up and go to the movement action and add another positive and negative one. So I'm gonna call it AD keys, and this one I'm going to call arrows, but it could be something like an Xbox controller or anything. So on the path, I'm just gonna listen to the left arrow on the keyboard, and to the positive to the right arrow on the keyboard. I save the asset. It's going to regenerate this player input, and now I haven't even touched the script. I just simply press play, and now I'm moving with the A key. Yeah, it moves. Now with the arrow, also moves, and to the other end with the D key, and also with the arrow, and it works perfect. You could do the same with the controller. So right now, if I add the Xbox controller, and here I just need to find the path. So joystick, let's say left, and here joystick right. It just works. I delete this for now. And now just add the jump to the player. Okay, so I'm gonna need another float value. So it's going to be a jump force. And if you open up the player input, I'm going to add another one called jump. So this time I'm going to leave it as a button, and in the binding I just listen and space. Or if I want another one like an up arrow, I can do that too. So I save this as asset. Here I'm just need a start function, and this time we are not reading a value or anything. We are simply just going to call a function. I'm going to create a simple function, jump. Let's make this a vector free, so we can specify different kind of jump scenarios. So rb dot add force, and this is going to be the jump force, and that's it. Right now we don't need the time.data time because we are just pressing it once. Input actions dot player dot jump dot, and here we have three options: started, performed, and cancelled. More on that in the video in the description. But right now we're just going to call the performed. So if we pressed it, so we are just going to subscribe to jump function. So the syntax is kind of strange, but especially for a beginner, but all you need to do is just follow syntax, just create a variable for the context, and then equals and greater sign, and just the jump function. So right now, when we press the space or the up arrow key, it's just going to call this jump function. We need to enable and disable it. Same thing at the disable. Okay, now at the player, we need to add some force on the y-axis. So let's say 500. When we jump, it should push it just slightly. So I would say start with 100 on the Z. So it not just pushes upwards, it's also going to push it like slightly like that. But let's try it. Okay, now just press space and now the arrow key and it works. I can move left and right. Awesome. Just a good practice. Come back to the GitHub desktop, save it, new input system setup and commit to main. Okay, so that's it for this video. And in the next one, we are going to make the camera follow the player. So check it out here.